Want to create images like this locally on your computer for free? In this tutorial, I'm going to show you how to build the basic text-to-image plus LoRA workflow from start to finish inside ComfyUI. Before we begin, this is the completed workflow we'll be building. I've custom built and organized it with instructions, notes, helpful links, and clearly labeled sections to make it easier to understand and reuse. Patreon members can download the finished workflow along with the reference files so you can follow along with the video or jump ahead whenever you want. I've also created the DOS Node Suite, which you can download for free through extensions in ComfyUI. The first part of the workflow we're going to build is the model section. This is where we choose the main checkpoint that ComfyUI will use to generate the image. I'm going to add a load checkpoint node by double-clicking on the canvas, searching for load checkpoint, and selecting it. From the dropdown, I'll select Minimix, which can be found at civitai.com or any website you find models, LoRAs, etc. to use. Your checkpoints are stored inside the ComfyUI folder under models/checkpoints. The load checkpoint node gives us three outputs that the rest of the workflow needs: the model, clip, and VAE. The model is used during generation, clip helps you interpret the text prompt, and the VAE will turn the generated latent result into an image we can see. Since the workflow includes LoRA support, I'm going to add a load LoRA node directly after the checkpoint. I'll click and drag from the model socket, release it, search for load LoRA, and select it. That places the LoRA in the correct part of the workflow, instead of sending the model directly into the KSampler. I'll also connect the clip output from the load checkpoint into the clip input on load LoRA. The LoRA can now influence both the model and the text guidance. From the LoRA dropdown, I'll select the Macama file. LoRA files are stored inside the ComfyUI folder under models/LoRAs. The strength values determine how much influence the LoRA has. We'll leave those at the starting values for now and return to them after the workflow runs. Next, we need to add the prompt section. This is where we describe the image we want the workflow to create. I'm going to add a clip text encode node for the positive prompt and connect the clip output from the load LoRA into it. The positive prompt describes what we want to see in the image. For this workflow, I'll enter masterpiece, best quality, Macama, chainsaw man, woman with red hair, golden eyes, braided hair, white shirt, black tie, confident expression, upper body portrait, anime style, detailed face, soft cinematic lighting. If the selected LoRA requires trigger words, I'll include those in the positive prompt as well. Now I'm going to add another clip text encode node for the negative prompt and connect the same clip output into it. The negative prompt describes things we want the workflow to avoid, such as blurry details, distorted faces, messy anatomy, or other unwanted results. I'll enter worst quality, low quality, zombie, interlock fingers, text, and watermark. Now we need to create the starting image space that the sampler will work with. I'm going to add an empty latent image node. This is where we set the width, height, and batch size. For this example, I'll use 512 by 768 with a batch size of 1. The empty latent image is not a visible image yet. It provides a starting latent space that the KSampler will use during generation. Next, I'm going to add the KSampler. The KSampler combines the model, prompt guidance, and latent image to generate the result. I'll connect the model output from load LoRA into the model input on the KSampler. Then I'll connect the positive prompt, negative prompt, and empty latent image to their matching inputs. For the starting settings, I'll use a seed 1, steps 35, CFG of 7.0, sampler DPMPP, scheduler simple. We'll take a closer look at the settings that are worth adjusting after the workflow has successfully generated an image. The KSampler gives us a latent result, so we still need to turn it into a normal image. I'm going to add a VAE Decode node and connect the latent output from the KSampler into it. Then I'll connect the VAE output from the load checkpoint into the VAE input on the VAE Decode node. Now the generated latent result can be decoded into an image. Next, I'm going to add a preview image node so we can see the results directly inside ComfyUI. I'll also add the DOL saved image node so the image is written to the output folder whenever the workflow runs. The DOL save image node gives us additional control over the file name, save location, file type like PNG, ICO, PDF, and more. It also controls metadata. You can use a normal ComfyUI save image node. Generated images are stored inside the ComfyUI folder under output. I'm also going to add the DOLS workflow timer as a bonus, so we can see how long the workflow takes to complete and give us an auditory noise when the task is also complete. The workflow is now fully connected from left to right. Now that the workflow is built, let's run it and make sure everything is working. For this first test, the goal is not to create the perfect final image. The goal is simply to prove that the completed workflow runs successfully from start to finish. I'm going to queue the workflow and let ComfyUI generate the image. And there we go. We have our first completed result. If you see an image here, that means the workflow is working and we're ready to make adjustments. Before changing anything, I'm going to save the workflow itself so we can reuse it later. This is separate from the generated image, which is already handled by the Save node. I'll go to File, select Save As, and name it Basic Text to Image LoRA Workflow. Inside the ComfyUI folder, saved user workflows are stored under user/default/workflows. Now we can make a few targeted adjustments. For a LoRA workflow, the main setting to watch are the model strength, clip strength, and any required trigger words. If the LoRA's effects is too weak, raise the strength slightly. If it overpowers the image or causes unwanted results, lower it. You can also change or refine the trigger words in the prompt depending on the features supported by the LoRA. The KSampler settings are worth checking as well, but we don't need a full sampler lesson here. Changing the seed gives you a different variation. Steps affect how many generation passes are performed, and CFG controls how strongly the results follow the prompt. You can also experiment with different samplers and schedulers to fine-tune the final look. After making one or two changes, queue the workflow again and compare the new image with the original result. And that's it. We successfully added LoRA support to the workflow. And now you can customize your images with different LoRAs, trigger words, strength values, prompts, and generation settings. As a reminder, Patreon members get access to the finished workflow, reference files, private Discord, personal help, and chat with other members. You can also use Discord to recommend DOS node suite ideas and vote on which custom nodes I build next. Thanks for watching, and I'll see you in the next one.